Okay, guys, today, inshallah, we're going to continue what we started yesterday. Yesterday, we started in section 2 of chapter 8. We're talking about the different types of chemical reaction. Just to remember what we said yesterday, we said whatever the kind of the chemical reaction, any chemical reaction must follow by 3 steps. First, breakdown of bonds which found between the atoms of the reactants. Then these atoms set apart and start to rearrange themselves. That's the second step. Then they are going to form a new bond which is more stable than the bonds which were found in the reactants. That's why the products always are stable than the reactants. So that's whatever the kind of reaction these 3 steps will be done. Regarding to how the reaction working, that means how much there are the reactants and the products and what happens between the atoms, we could classify the chemical reaction into 4 categories. Who can remind me, guys, what are the 4 types of the chemical reaction as we watched them in the video yesterday? Anyone can remind me, guys? Okay, yes, Yusuf.
Single replacement, double replacement,
Yes,
decomposition,
good.
combustion, synthesis.
Brilliant. Okay, so you said all the 5 types are good, very good. Okay, so we could find that we have 5 types of the chemical reaction. First of all, we have synthesis, then decomposition, single replacement, double replacement, and combustion. So here, like this, we start yesterday to explain the synthesis reaction. So who can tell me what meaning by synthesis reaction or what will happen in a synthesis reaction? Okay, guys, anyone can tell me? Synthesis from the English word synthesis means. No one know what meaning by synthesis reaction? Okay, guys, synthesis reaction was a type of chemical reaction in which two chemical substances, they could be elements or even compounds, that they are going to combine together to form just one product. So in the chemical reaction, we're going to find the reactant, the material which is already written before the arrow, more than the material, then they are going to be formed after the arrow. That means we have two elements or two compounds that they are going to combine together, forming one product only. So that's here a reaction of building or the reaction of creation, making new substance, okay, which is just combination of all the reactants. Yesterday we start talk about the combination of different elements, and we observed that different elements that they could react with each other. So we observed that metals could react with some metals, forming ionic compounds or ionic bonds, okay, and that's considered as a synthesis reaction. Also, we observed that some non-metals could react together, that producing covalent bonds. So that's also synthesis reaction. Even some metals, they could react with some non-metals, forming covalent compounds if the difference in electron affinity between them is less than 1.7, as we studied before, and that's considered to be a polar covalent compound and still a synthesis reaction. And we get a lot of examples about synthesis reaction as we observe. And also we said that in transition metals, they may, during synthesis reaction, they react in different ratios or different amounts regarding to the amount the other material that you're going to react with. For example, as we said, iron once it react with oxygen, it could form iron 2 oxide or iron 3 oxide. That means the oxidation number of the iron could change, depends on the amount or the availability of oxygen. If the oxygen is available or the amount of oxygen is too enough, so in that case the iron could lose 3 electrons, and in that case it would be a cation with positive 3 charge. Okay, while if the oxygen is not that enough, so the iron will lose just 2 electrons, and it will be a cation with positive 2 charge. So today we're going to continue here. We said that also we could observe that metals, they could react in a high rate with halogens, because we know that metals, okay, found in the left side of the periodic table, while halogen, that group 17, the last, the group before the last in the periodic table. So we could find that metals in group 1 and 2, they could react vigorously with halogens, and they producing ionic compounds, like one sodium react with chlorine producing sodium chloride, one potassium react with iodine produce potassium iodide, and so on. Also, we could find that other metals, transition metals, okay, which found in the middle of the block of the periodic table, they could react also with halogens, but in that case, they may not form an ionic compound. It may be a polar covalent compound due to the little difference in the electronegativity between the elements. But for example, we could find that fluorine, because it's considered the most reactive halogen or the most reactive non-metal, it could react with different metals and forming different compounds. Approximately, fluorine react with all metals, okay, in the periodic table. So for example, here we could find that it could react with sodium, producing sodium fluoride. Also could react with cobalt, producing cobalt fluoride. You're reacting with uranium, producing, okay, uranium fluoride, and so on. Okay, like this, we could find that fluorine reacts with all the metals. Here, group one, alkali metal, cobalt that run from transition metal, uranium, one of the lanthanides, which are actually radioactive material. So here, like this, we could find that react with the different metals that found in the periodic table. And this, okay, or usually once the metal react with halogens, it produce salts, and the category which we call it that due to combination of metals and halogen, we call them salts. These salts actually have many uses, or we can use it in different purposes in our daily life. For example, sodium fluoride, as you can see here, is added to many capillary plus water supplies to trace amount to provide fluoride ions, okay, which help to prevent tooth decay. That's always when you get a toothpaste, you're gonna find with fluoride ions. Okay, so these fluoride ions actually make a kind of protection layer in your teeth enamel. Okay, which prevent the teeth cavities and like this. Okay, that so that's one of our daily use you can find in our toothpaste at home. We also can find that copal fluoride, COF3, is a strong fluorinating agent. Okay, that means also could release fluorine in high amount. Okay, so like this, we find that this kind of reaction we already apply, or we make these types of reaction, we create this kind of compounds to have or to make certain purposes, or to use it in some usages or in our daily life. So here we can find also synthesis reaction could involve a reaction between two compounds, not just two elements. Okay, all what the examples we explained before, there were two elements. These two elements could be metal and non-metal, or even two non-metals react together forming one compound. But here we pass to another hand, we could find that oxides, that mean already the oxides of some metals, okay, they be able, or oxides of some metal or oxides of some non-metals, okay, like calcium oxide, sulfur oxide, whatever. These oxides, they could react, okay, with water, react with oxygen, and so on, and produce a larger molecule, or a larger compound, as we can see here. For example, calcium oxide. The calcium oxide that is already a compound reacts with water, which is another compound, and that's produce calcium hydroxide. So here we could find that here it's a synthesis reaction. How could we know it's a synthesis reaction? Because we have two reactants yields one product only. So like this, we could figure it's a synthesis reaction. So the calcium oxide, for example, once it reacts with water, it produces calcium hydroxide. This calcium hydroxide, actually called, this one is used in making the cement, okay, which is used in the construction and building purposes. So the calcium oxide actually have, like we said, that a common name, we call it lime, while calcium hydroxide have another common name that, okay, we call it, or that's what it is known as the slaked lime. That is one of the most ingredient that found in the cement, as we said. So it is used in the construction and building purposes. Also here we could find that sulfur oxide could react with water, that producing, okay, so here that we could find it producing the sulfurous acid. So sulfurous acid different than sulfuric acid, it just less by one oxygen. So sulfuric acid H2SO4, while H2SO3 is sulfurous acid. So once sulfur dioxide reacts with water, it produces sulfurous acid. So here actually sulfuric acid once it, or sorry, sulfur dioxide, once it rises from the chimneys of factories and so on, it could react with the water vapor that found in the clouds, and it may that form a kind of pollution, okay, because it will forming the sulfuric acid, and that later will turn into sulfuric acid, and then it will fall down with a precipitation, which called the acidic rain, and that's one of the most important features of the air pollution, or consider that air pollution. That's why we always advise that factories must be built out of the cities or countries, or just be surrounded by a huge green tree to be able to start to reduce this amount of this effect of pollution. Also, here we'll find that okay, calcium oxide could react with sulfur dioxide, okay, and that's produce a okay, that's produce calcium oxide. So calcium oxide here react with sulfur dioxide. That's called producing calcium sulfurs. Okay, so that's also a synthesis reaction that represents the reaction between two compounds and producing a new one. So here, all these guys, we could find that we have many of synthesis reaction. So actually, guys, here are the question. While we are studying this lesson, should we memorize all these chemical equations? Okay, actually, you should understand this chemical equation. Simply, you should know because they are very easy. We just have two reactants that are gonna yield one product. So per to understand them or to know them in word equations, then you by using the periodic table or by memorizing the symbols that we get used to use them a lot, you be able to write the chemical equation in your own way because you already trained how to write the chemical equation. So we will not memorize it as we are gonna predict or are gonna be able to write them. Just you need to know or just need to memorize them in the word equation. For example, magnesium react with fluorine to produce magnesium fluoride. So I know what is the symbol of magnesium, what is fluorine, and what is magnesium fluoride, and so on. I could build the equation in my own way. Okay, so here like this, that is synthesis reaction. Anyone have any hard question or something is not clear regarding to the synthesis reaction, guys? Any hard question, guys? Okay, so now we're gonna pass to the second part, which is a decomposition, the second type of a chemical reaction. So decomposition is totally the opposite of synthesis reaction because in decomposition reaction, we're gonna have a one compound, okay, that will gonna break down into elements or even smaller compounds, okay? So we're gonna find the opposite, as we can see here, the equation. Okay, so ax yields a plus x. So of course there is no compound ax or no elements a and x, but just we illustrate the idea that we have one compound that can break up parts into smaller compounds or into elements. So we have different types of decomposition. Sometimes we have decomposition by using electricity, so we call this electrolysis, or we the most decomposition happen by using heat, and we call this the thermal analysis, or we said that breaking down by using heat. So we said that first example here we have the electrolysis of water. Okay, water is a very stable compound actually that we if you get water and put it in a bottle and you left it for many years, actually it will not decompose, it will not break down. But okay, if I need to break the bonds which found between the water atoms, that means between hydrogen and oxygen, so we must supply this substance with a large amount of energy. So we could use electricity. Actually, there was a scientist, his name is Hoffman, who make a device called Hoffman voltmeter that is used to break down water by using electricity. So we could find here, guys, the water, once we put it in Hoffman voltmeter and we're just adding electricity, the water could break down into its components. It's gonna break down into hydrogen and oxygen, two separated gases. Okay, so like this we could find that is a decomposition reaction, one compound break down into two elements. Okay, so here we need to set a definition. What I mean by electrolysis? Electrolysis is decomposition of a substance by using electric current or by using electricity. Okay, so the other type here we have the decomposition by using heat. So we have categories we're gonna note. Okay, we're gonna just talking about some categories. First of all, we said that oxides, okay, that mean whatever that this oxides. For example, here the mercury oxide, we have HgO, that's a mercury oxide. So once it heated, this triangle above the arrow, remember it means heat, okay? So this means the mercury oxide, without heating, it will not break down. So we must heat this. So once we heat, we're gonna find it's gonna break down into mercury, the liquid metal, the only liquid metal, and oxygen gas will evolve. So always here we find that breaking down or decomposition of oxides, producing the metal and the oxygen, or producing the metal and the oxygen according to what substance you decompose. So like this again, guys, here we find that we could find that binary compounds, it means the compounds that are just made of two elements, okay, only. So that's why we call binary compounds, like water, like mercury oxides here, they're just made of two. In the first case, just hydrogen and water. So once we supply or once we apply electricity on water, okay, so could we just hear a question, guys? Could we break down water by using thermal energy? That means could I heat water, okay, until they break down into hydrogen and oxygen? Okay, 2 marks bonus for the one who answered this question.
Yes.
Can we?
Yes.
So that means I could heat up the water until they break down into hydrogen and oxygen. Yes?
If you break the bond,
I'm asking now, could I break down, could I make a thermal decomposition of water, or it must be electric decomposition?
you can use thermal.
What?
You can use thermal
I
decomposition.
can use thermal decomposition. What's your opinion, guys? Do you agree with Hassan's opinion? Do you agree?
لا.
So Yahya said no. Could you tell me why? Okay, so let's make them 5 marks. But just I need the answer in just 1 minute.
Yeah, I agree.
You agree? Okay. So actually, guys, no, I can't. Do you know why? Because as we studied last year in biology, okay, the water have high heat capacity. That means water absorbs a lot of heat until it, okay, before it breaks down. So if you keep heating water, actually you are gonna reach 100 degrees Celsius, and water will start to evaporate and turn into water vapor, and in that case, it will not break down. You get this, guys? So in that case, okay, water have high heat capacity. It will consume a lot of energy, a lot of thermal energy before breakdowns. Actually, they will take a lot of heat, then they will turn into vapor, then they will escape. Okay, and in that moment, you will not break them down. So to break them down, we use electricity. That's why we call the electrolysis. Okay, is the way that we break down water. Is it clear, guys? So here we said that the binary compounds, that mean compounds which are made of 2 elements, they could break down into the 2 elements which already the ingredients of the compound we start the reaction with. So then we pass to the other categories of the decomposition reaction. We're going to talk about categories of compounds. For example, the decomposition of metal carbonates. If we have a metal carbonate, carbonate is CO3, one of the polyatomic ions, or it's a radical, carry -2 charge. So calcium carbonate, okay, that's metal carbonate. So the decomposition or the thermal decomposition of carbonate, metal carbonates, whatever the metal carbonates, could be calcium carbonate, sodium carbonate, magnesium carbonate. So we don't care about what is the metal, we just care about the carbonate. So the decomposition of a metal carbonate always produces the metal oxide and carbon dioxide gas. Okay, so simply we are gonna break this carbonate into oxygen and carbon dioxide. Oxygen will still bonded to the metal while the carbon dioxide will be released as a gas. So here again, decomposition of metal carbonates always produces the metal oxide and carbon dioxide. So it not must to get the same equation. Whatever the equation is, for example, instead of CaCO3, we're gonna make it MgCO3. So in that case, it will produce MgO plus CO2. If we make it Na2CO3, so it will produce Na2O plus CO2, and so on. So the metal is not the problem. Whatever the metal, it could be changeable, that whatever the metal is. But always, as we have this fixed part, the carbonates, it always produces carbon dioxide and the metal oxide. The other category, the composition of metal hydroxides. Okay, so metal hydroxides, once they break down by heat or thermal decomposition, it always produce the metal oxide and the water vapor gas. Okay, so it's still the same. We don't care about the metal. We just care about the anion part or the negative part of the compound, which is the hydroxide group, another polyatomic ion carry -1 charge. So here, once they are gonna decompose by thermal energy, we're gonna find they will produce the metal oxide and the water vapor. So also here we can say, for example, NaOH, okay, or 2NaOH. They are by thermal decomposition. They will produce they are going to produce Na2O plus H2O. It could be MgOH by 2. So by thermal decomposition, it will produce MgO plus H2O gas and so on. So the metal could change, but the result always will be the same. That means it's the metal oxide and the water vapor will be released. Here we find that the breaking down of chlorate ClO3. Okay, that's another polyatomic ion. So the decomposition of chlorates produce the metal chloride plus oxygen gas. Okay, so here it's different. It's not the oxide. We're gonna produce the metal chloride. Okay, so here we find that chlorate is breaking down into metal chloride, and oxygen gas will be released. For example, here potassium chloride. So it could be sodium chloride, it could be calcium chloride, whatever the metal could change, but always producing the same. And as we observe here, we have another condition that is found already under the arrow. So beside heating, we should use a kind of catalyst, magnesium oxide. Okay, so sorry, manganese dioxide. So this manganese dioxide is considered as a catalyst that speed up the chemical reaction, because potassium chloride actually is a very stable reaction, stable compound, sorry, which requires a lot of heat, and we need to use a catalyst to speed up this chemical reaction. So here, decompositions of acids. Acids could decompose or could break down. So as usual here, that's carbonic acid. So carbonic acid is very weak acid. It could already break down in the normal room temperature, even without heat. That's why we didn't draw the triangle above the arrow. It could just break down in the room temperature. So we find that H2CO3, it's here, this acid already contains the carbonate group CO3. So as we think or predict, it will produce the water, okay, and carbon dioxide. Okay, while here we find that H2 is for sulfuric acid. Sulfuric acid is a stable acid, so it's required to be heated. Okay, so heating or sulfate group, once it breaks down, it always produce sulfur trioxide, and oxygen will attach to whatever it is. So I could predict here that metal sulfates always produce the metal oxide and sulfur trioxide. Okay, so like this guys here, that represents how the decomposition reaction happen. Okay, so decomposition reaction, as we said, is completely the opposite of synthesis reaction. So any hard question to what we explained, guys? Any hard question to the part? Okay, guys, that's what our lesson for today. Be ready for next for quiz tomorrow. Okay, the our regulation or our instruction for the quiz is always the same. Be on the meeting on time. I'm gonna send the quiz through the WhatsApp. Okay, you're gonna answer it and just make submit after you finish your answer. So see you tomorrow. Thank you. Goodbye.